So 4.1 is called absolute extrema and the mean value theorem. So we're only going to deal with the absolute extrema today, and then we'll do the mean value theorem on Monday. Okay, so this first little box is all about extrema stuff. Okay. Extrema is, good question, is basically all of your maximum and minimums. Okay. So we did do this last year, but we did it in a very different way. We used the calculator last year to find extremas. This year we're going to do it by using calculus.
No.
Yeah. Okay, so let's just say I have this random function, right? Something like so. You don't have to, it's up to you. But you guys understand that this point down here, at the very, 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 very bottom, is an absolute maximum. Or excuse me, not a maximum. A minimum. Minimum. Okay, what's this one right here? Absolute? Relative. There you go. Okay, so this is a relative max. This one right here is a relative minimum. Okay, what is the absolute maximum for this particular function? Okay, there is none. Okay, there is no absolute maximum value for this function because it keeps going up to infinity. There's never a stop. Yes. Then there would be an absolute max, yep. And no absolute min, right? Right. Okay. So the thing that's important for you to understand about these absolute max, absolute mins, relatives is that you are listing the absolute maximum, minimum, y values. Okay? So if they ask you to find the absolute maximum, you're going to tell me what the absolute max y value is. Okay? Okay, so that is just all of the extremas. So that's these things up here. Okay, so extremas are maxes and mins. Okay, the very last one, these critical numbers. This is huge. Okay, the whole idea of critical numbers are just big. Okay, so a critical number is any number that the original function does not exist at. Okay, because you cannot take the derivative of that. Okay, so that makes it critical. And anytime the derivative is equal to 0, that's critical, or the derivative is undefined. Which means what? What makes something undefined? Dividing by 0, vertical asymptote, exactly. Okay, so if we take the derivative, we can set it equal to 0 to find critical values, and any value that makes the denominator 0 is also critical. Got it? Okay. All right. So procedures for finding your absolute or global extrema, all you're going to do is you're going to first find critical values. Okay, and then all you do to find those y values is you plug those critical x values into the original function and then figure out which one is the biggest and which one's the smallest. Okay. Okay, so let's start with these first examples with this drawn function over here. So first question, what is the absolute maximum of the f function? 4. Good. Everybody okay with 4 because it is the highest y value that exists? Nice. Okay, so at what x value does the f have the absolute maximum? Okay, so its corresponding x value is -4. So what is the absolute maximum point? -4, 4. Okay, so what I think they're getting you to understand in those 3 questions is just the different ways they would ask about extremas. Okay, so if they ask you about the absolute maximum or minimum, you're going to give an answer that's the y value. Okay, if they're looking for the x value, they're going to specifically say, what's the x value? Okay, or they'll say specifically the point. Okay. Question 4, what is the absolute minimum of this function? Okay, so what's very interesting about at -2? There's a hole. Okay, so we can't say at -2. So what value is approaching -2? Exactly. Nine. Is it a finite value? No. So it doesn't exist. Okay, because we cannot really say infinitely close to 2, we have to say it does not exist. Right, absolutely. It has to be a concrete value. Okay. For question number 5, at what x values does f have a relative minimum? Okay, what? Negative what? -3. I definitely agree with -3. What else? 1? No, it wouldn't, because it's an absolute idea. It's the furthest one down. There is one more. At 2. Okay, so at 2, even though there's a hole in a function and that point drops below, it's still considered a relative minimum. You count the point, the actual value, the concrete value. Yes. Sure. Okay, for question 6, at what x value does f have a relative maximum? Where is our relative maximum? Definitely -1. Whoops, I almost wrote x. -1. Any other places? 2. So what's happening at 2? What's at the very top of it? A hole. So can we say the hole? No. So since that's the same idea as we can't get infinitely close, we can't even say that that's a relative max because we can't say that's the spot. Okay. So only -1 is the only place where you have a relative maximum. It's any top of a curve that exists, and since at 2 there's a hole, it doesn't exist at that spot, we can't include it. It has to actually exist as a point on the top of the curve. Yep. Okay. So that's nice when they give us a graph, but they probably won't always give us a graph. Okay, let's do it when they give us a function. So it says to find the global extremas of our function on the interval between -1 and 3. Okay, so the first thing we're going to do is we're going to take our function and we're going to derive it. Okay, so we're going to find the derivative. So what's the derivative of 1/3 x cubed? X squared, right? Because you divide by 3, right? And then what's the derivative of 2x squared? -4x. Okay, so remember that in finding critical values, first of all, on my derivative, is there any value that makes the denominator 0? An undefined value. No, none at that point. Okay, so the other place for critical values is when my derivative is set equal to 0. So if I set this equal to 0, I can come up with some critical values. How would I solve this quadratic factor? So what could I pull out? X. So I would be left with x minus 4. So I have 2 critical x values, which are 0 and 4. Perfect. Okay. So now the next thing I want to think about is my interval. Okay, so I'm only kind of like zooming into this one window between -1 and +3. Okay, so if you look at the 2 critical values, what do you notice about that window? Okay, only 0 works. 4 is not within the range between -1 and 3. Okay, so we're going to exclude that, even though there's probably something going on in the graph. We're going to ignore that fact. Okay, and what we're going to do is we're going to put in the 2 endpoints and the critical value. Okay, so we're going to go back to the original to plug these in. So we're going to do f of -1. Okay, so if I plug that in, let's see, -1 cubed minus 2 times -1 squared. So Negative 1 cubed is negative 1, so that gives us negative 1/3. And then that would be minus 2. I'm going to put that in terms of thirds really fast. 2 is the same as 6/3. So that makes negative 7/3. Okay. Okay, the next critical value that we found was 0, so I'm going to plug 0 in. That one's easy. Can we all conclude that one? Plug 0 in, what do you get out? 0. Okay, good. And then if I plug 3 in, 3 cubed is 27. 27 divided by 3 is 9. So you get 9 minus 3 squared is 9. 9 times 2 is 18. So it's 9 minus 18. Negative 9. Okay, so now all I have to do is say which one is the max and which one is the min. Okay, so which y value is my max? 0. So I have a max. And I'm going to say of f. Okay, so since they're giving me the notation of f of x, I'm just going to say that f is 0, because that's my y value. Just using their notation. And what was the minimum value? Negative 9. Nice. So what do you guys think? Hard? It's not too bad, right? Okay, so let's take a look at question number 8. So, same idea, we're going to find the absolute max and mins of our function on our interval, this time between 0 and 5. So what do I do? Derive it. Anybody know how to derive absolute value? It's illegal? Well, it can be done, but you'd have to write 2 separate functions for it. So what I'm going to do on this one is make this as easy as possible, and I'm just going to graph this, because the absolute value of x minus 2 is very easy to graph. And I can be extremely accurate in my graphing. What does the absolute value look like? It's a v. Okay, so if I have x minus 2, what direction is it going to go? To the right. To the right 2. So I go to the right 2, it has a slope of 1, so I can go up 1 over 1 in both directions. It's going to cross the y value at 2. Okay. So, if I'm looking on the interval between 0 and 5, 1, 2, 5, there's 5. So we're looking here to here. Which one is my max? Which one gives me my highest y value? At 5. Okay, what is the y value at 5? 3. How did you get that? Magically? How could you get it? So you can get it from the slope just by looking at the graph, because it goes up 1 over 1, up 1 over 1. Or you could just plug 5 into the function, because 5 minus 2 is 3, absolute value of 3 is 3. So we can say the absolute max of f is equal to 3. What's the absolute min? Good. So the lowest y value is at 0. Yeah. So global would just mean within the interval, within the area. So absolute, I mean, if they give you an interval, you're still looking globally. So, yeah. Okay. So last question here we're going to do, I think. Yep, this one. How would I do question number 9? Okay, so again, finding Extrema, what are they asking us to find? Okay, that's how we're going to do it, but we're going to find a max and a min. So we're going to start by finding the derivative, unless you know what this function looks like very accurately. So what's 3 times 2/3? 2. 2x. And then what's 2/3 minus 1? Negative 1/3. And then the derivative of 2x is 2. So if I rewrite that, that would be the same as 2 over x to the 1/3 minus 2. Okay, so first thing I want to think about is my critical value. Is there any value that makes a denominator 0? Which value? 0. Okay, so see how the x is in the bottom there? I have a critical value at x equals 0 because 0 makes that function undefined. Okay, and then how do I find the rest of them? What do I do with that derivative? Set it equal to 0. Okay, so how would I solve that? You add 2, so I get 2 is equal to 2 over x to the 1/3. Then what? Multiply the x to the 1/3 out, so 2x to the 1/3 is equal to 2. Then what? Divide by 2. So x to the 1/3 is equal to 1. So then how do you get rid of it to the 1/3? Cube it. And so what's 1 cubed? 1. Okay, so I have one critical value at 1, so that's going to be a maximum or a minimum. I have a critical value at 0, and then my interval was between -1 and 3. So I got to use all 4 of those, right, to find my extremas? All of them, yep. Should we split this up? You guys do this one, I'll do this one. I'll do 0. Okay, let's do -1. That's not too bad. -1 to the 2/3. What's -1 to the 2/3? Because that's the same as -1 squared. 1. And then the cube root of 1. Also 1. What's 1 times 3? 1 times 3 makes 3. And then, so we got 3 plus 2. 3 plus 2 is 5. We plug 1 in. That's going to give us 1 to the 2/3 is 1. 1 times 3 is 3. 3 minus 2, 1. And then when I do 3, oh, this one's going to get yucky. 2, 4, 1, okay. 0.241. Okay, yeah, because that one turns out to be the cube root of 9, which I'm going to let you calculate. Okay, so which one was the max? So what was my max? F is 5. What's my min? 0. Done. Not too bad? Piece of cake, right? Alright, so we'll save the mean value theorem for Monday. So I'm going to give you guys so I'm going to give you 1 through 6. 1 through 6.